aluminum and stainless steel, mainly high quality weld, no weld spatter because no filler metal, little or no post weld cleaning because no flux is used. Flux is covering material, so after welding it has to be removed because those are impurities kind of. Now I am sharing the video. If audio is not coming, then just inform me.
Not audible.
Sound is not coming, sir.
The audio is not coming. Rakho, let me play from my side. You unshare? Okay, then so that I can play from this side. Sorry, not this one.
Okay, now I will show you manual metal arc welding.
Is the audio coming?
And for this welding, we require a
Yes, sir. Yes, sir. Yes, sir.
we are taking AC type and DC type. This one is the DC rectifier. And in this machine, there are two terminals. One is the positive terminal and another negative terminal. And now in this connection, the negative terminal is attached to the working table, and the positive terminal is attached to the electrode holder. So the electrode that you attach on the electrode holder, that is positive, and the workpiece is the negative. So this connection is electrode positive. This is EP, and this was the current knob. According to the metal thickness, you have to set the different currents. Here I have taken 5 mm thickness mild steel. That's why I am setting the current near about 100 ampere. And this one is the electrode, and you have to choose the electrode according to the material of the plate. This material, you see, the two mild steel plates. You have to join the two mild steel plates, and that's why I have taken mild steel electrode. And the diameter of the electrode is 3.15 mm. 3.15 mm diameter. And you have to choose the diameter of electrode according to the thickness of the metal. And you see, there is a covering, blue type covering on the electrode. That is called as flux. This flux is coated over the electrode. That is rutile type flux. And this flux is titanium oxide. And the flux is coated over the electrode because at the time of welding, when flux burn, a gaseous shield will form. That gaseous shield will protect the molten metal from outside oxygen. And also this flux will provide arc stability at the time of welding. That's why we are putting the electrode. And you have to attach the electrode on the electrode holder. Now, since the electrode is the positive, so electrode holder is positive, the electrode is positive, and this is DCEP, direct current electrode positive. In this case, more heat is generated at the electrode end. You may change the also connection. That means you may attach the electrode to the negative and working table is working to the positive. At that time, more heat will generate at the workpiece end. Here I will show you two types of joints, and you see these are the two plates you have to join, high steel plate. First I will show the bord joint, after that I will show the lap joint. Okay, first we will go for the bord joint. Before joining fully, first you have to join the two ends, because if you would not join the two ends, directly weld from one end, due to the more heat generated, the other side may expand. That's why first you have to join the two ends. And for welding, you have to take some safety items. For hand safety, you have to wear gloves, and also body safety, you have to wear apron. And this is auto darkening helmet. You can also take other type of shield for safety your arm during welding. Now I will show you the welding. First you have to generate the arc. How will generate the arc? At the time of initiating the arc, you have to touch the electrode with the workpiece. If you keep it on touching, then circuit will close, the electrode will stick to the metal, because more current will draw, and suddenly the end of the electrode will melt and solidify, then it will stick to the metal like this. And that's why after touching the electrode to the workpiece, you have to take a little away or little above to continue the current. And the gap between the electrode and the workpiece, that is called as arc length, you have to set according to the diameter of the electrode. That is, it may be now in this case up to 3 mm. You may maintain the arc length. First you have to, I will join the two ends, then you have to remove the slot. Then you have to continue holding from one end to other end. Now you see, after melting, the flux is just coming to the upper part of the welding. Now the flux after burning turn into slab, and you have to remove that slab. First you have to allow it to cool, and after that you have to hold the plate with the help of tongue, and using the hammer, chipping hammer. This is the chipping hammer. and using this hammer you have to remove the slab. Then this one is the wire brush, and using wire brush you have to clean the slab. This is the board joint. Okay. Now we continue. Now we continue the lap joint, and at the time of lap joint, you have to take also two plates, and you have to overlapping one plate upon another. Okay. Then you have to also join the two end initially, and after that you have to continue the welding also. Good.
Acha. Let's see. Students have some doubts, so I'm one by one clearing doubts. Huh. A direct wire is not visible in video. In the video, if it is not visible, but it is there because current connection should be there to create the arc. Next is the work in the video, the work plate connected to negative terminal of power source. Here the negative terminal, say, see, for this reverse and straight polarity, if suppose the electrode is connected to the negative terminal, okay, then the electron will flow from the electrode to the workpiece. Now, in this way, you are getting some extra bombarding of electrons on the workpiece or on the weld portion, weld zone. So you are creating some extra amount of heat. So when the negative terminal is connected to the electrode, then you are getting some more amount of heat on the surface as compared to when the negative terminal is connected to the workpiece. Now next question. I think it is like the same flux as in, this is not a question. Flux as in metallurgy. Flux is simply a substance which is used to combine with the metal oxides or impurity just to remove those impurities. What is flux? I explained. Slide note. Plasma is a state. Plasma is a state when electron is ejected. You can say. In a way, what is the use of post treatment? Post treatment is just to making metallurgical uniformity. I told you earlier those grain parts. So these are just for managing uniformity across the metal or across the workpiece. how oxyacetylene welding will cut the metal. See how cutting is done. You can see in oxyacetylene flame, there is a flame which is created by the stream of mixture of acetylene and oxygen. Now suppose while melting the metal which you want to cut. Now while melting, if you increase the flow of oxygen, so you are just increasing the flow of speed of flow of discharge. Okay, so what will happen, the molten part will flown out or blown out because of the stream. So in this way you can cut a metal sheet by using oxyacetylene setup. O2 and C2H2 are equal in volume. Means you can change the mixture for creating three types of flames.
Not audible.
Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Uh-huh.
Sir.
Isn't acetylene limiting reagent? Limiting right now I have no idea of limiting reagent, but acetylene is a fuel from where you are getting the heat source by burning in presence of oxygen. Now answers. Is there is need of HET of combustion, heat of combustion of other components? No, basically heat is liberated uh, out of acetylene and out of carbon monoxide. Oxygen is just a helping oxidizing reagent. So you don't need of other means you won't get heat of combustion of oxygen. How heat will burn itself? Heat just help in burning. So here only means you have only heat of combustion of acetylene, and in the second stage reaction heat of combustion of carbon monoxide. Interstitial compound. Acha, I just used an example of that lattice for making you understand that surface hardening. When not filler is used, say when you are joining some thicker plates, okay, then while making the welding, the weld part of the slabs is not sufficient to fill the gap, so in that case you use filler material. Why do a sound is heard in oxidizing flame? See, as it is a exothermic reaction. So exothermic reaction means heat is getting liberated. Okay now, and heat you can also heat liberated means there is more temperature, and in kinetic theory of physics you can understand temperature is the kinetic energy of the molecules. Okay now, means more temperature means more chaos or more disturbance between the molecules. So from where or from that sound is coming, means some of the energies gets converted into sound.
Sir,
Ah.
The other type of flames too were exothermic in nature, no?
Means all heat is generated, energy is released in exothermic reaction. So here
Yes.
all the process is, yeah.
Uh, but,
What
uh,
your
bu-
question?
but
Sorry.
on the specific, when we increase the oxygen volume in
Hmm.
comparison with acetylene, only then the sound can be heard, not in other cases.
Means if there is disturbance, then there is some kind of sound you will get. Maybe the quantity of sound or amount of sound will be a lesser or larger. That's the only difference.
Okay.
Yeah, the heat was maximum in that case. No, they told that it is 35000.
Uh-huh.
So it would be more sound.
The inner cone where the first stage of reaction is taking place, it is liberating more heat. So here temperature is more. So basically the melting part is done by this because the temperature is very high. And outer feather where temperature is lesser, it helps in preheating. So it also helping in melting, but it itself not melting, it's just preheating. But when you are using, say, some metal for joining whose melting point is below the temperature created by the second phase or feathering zone, then it can also melt. So that is not a restrict limitation. Which zone of flame is used for? I explain right now. The tip from which C2H2 is coming is of which material? The tip, that tip, I think that is copper or brass. I mean, I'm not sure that tip, but you can check in net uh, or because in the slide it is not there. I'm sorry for that. I'm not remembering. What is the material, tip material? So it is brass or copper. Maybe I'm wrong. Please you ensure with net. The basic purpose of that uh, torch is just to produce that flame, and also that it should not melt. Okay, so the technical funda is that the tip should not melt by the heat of that flame. So you need a material whose melting point is more than 35,000, sorry, 100 degree centigrade. So you can use whatever material is whose melting point is more than 3500. So you can make torch. What thing should be kept in mind while setting pressure? Acha, in oxyacetylene setup, just in the flow, the flow of the mixture is taking into mind. What is the working pressure needed? See, here all the experiments is done in ambient pressure. in the video in manual arc welding. It is just in the ambient pressure, and next is soldering same as welding. See, both are joining processes, but in soldering you are using less low melting point material for joining processes. Means the strength is not, you are getting not much strength as compared to welding.
Sir,
Yeah, yeah.
sir, in arc welding, when is the thin and thick diameter electrode used?
Thin and thick diameter use when you have to deposit larger material, when you have larger volume gap, you have to deposit more filler material, then you are using larger diameter, and when you don't, then you are lesser diameter.
Okay, thank you, sir.
How welcome. How to reduce surface contamination? See, surface contamination are simply you are removing the upper layer of the material, and in the molten part it is done by the that protective layer of oxide, metal oxides. If there is welding of two types of metals with different crystal properties, then the joint will have the crystal properties same as that of which metal? See, you have to see, means for uniform strength you have to match the crystal properties of the weld and also of the other two parts. But here the doubt is, if there is welding of two types of metals which have different properties, then the joint will have crystal properties same as that of which metal. Here the crystal properties in the weld zone will happen how the mixing or how the solubility of two metals has been done in the weld part. If it is heterogeneous, then where the part 1 metal is there, then it will show the crystal property of that part, and when there is deposition or zones of second part metal is there, it will show the crystal properties of that second part. Am I clear?
Yes, sir.
Is there a PPT? No, this is not a question. I think all
Sir, can
doubts
you
has been
explain
covered. Huh.
the cooling part you have explained in the beginning of the slides?
Acha, okay. Let's little time, but I will make you clear. I'm sharing a screen for making you. Can you see the paint?
Yeah, yes, sir.
See that cooling part. Okay, now see this is some is a volume where say you have liquid part, liquid metal. Okay, now so while cooling or while solidification, do you think that whole volume solidify at the same time?
No.
Practically, can you think? Because everywhere for at the same time solidification, every point should have same temperature change. Are you agree?
Yes, sir.
Okay, now, but you won't get a uniform temperature distribution across the volume, because at the surfaces it has lower temperature than at the center, because heat loss is more at the surfaces than in the center. So you have different kind of temperature changes. So where the freezing temperature will reach, from there solidification will start. So from the beginning they will form a small points or small spheres. They are called nucleus points. Okay now. Now how rapidly? If you are cooling very rapidly, then these spots will be more, because those spots of freezing spots will reach more quickly. Okay, are you getting?
So the cooling is done manually or it happens automatically?
That I will explain later, but are you getting that if the cooling rate is
Okay,
very
okay.
fast,
Yes,
then
yes.
you will get more solidification points. Okay now. Now if the cooling rate are more, then for the same volume you are getting more solidification points. And if the cooling
Yes.
rate is lesser, then you are getting lesser solidification point as compared with the same volume. Now if the cooling rate is lesser, say option 1, you have low cooling rate, and option 2, you have high cooling rate. So in which case you will get finer grains, in high cooling rate or low cooling rate?
Lower.
Low cooling.
Low one. How
Low.
low one?
Low.
Because in low cooling rate you are getting lesser nucleus points, solidification points. So after solidification volume is constant, a number of solidification is lesser in compared to high cooling rate, and after solidification volume is constant, so you will get larger grains now in low cooling rate. Are you getting? Because space volume is constant,
Okay.
cooling rate you have more number of solidification, then for the same volume they have more solidification points for the same space, so they will be finer now, smaller grains in high cooling rate. Am I clear?
Okay. Okay.
Sir,
Now
what?
each sorry.
Continue, sir.
And each grain is just adhered to the subsequent nearest grains. Now if you have finer grains, means more number of grains, and more number of grains means no more surface of adhesion. So that is why in high cooling rate you are getting more strength, is the grains are very finer, so they have more surface area of adhesion. Okay. Now one of the students question was how you control the cooling rate. Simply introducing the environment. Okay. There are many kinds of metallurgical processes. Say quenching. In quenching, what is done? The heated part is just quenched into water. So you are just increased the cooling rate. So in that case, you will get finer uh, grain sizes. So you are simply hardening the material. Am I clear?
Yes, sir.
Is there any doubt? Because
Function of seal.
time is, we are out of time.
Again, sir.
We have 5 minutes. Sorry.
So, what is the function of shielding gas?
It's shielding. It is shielding the molten zone from the atmospheric gases. Otherwise, the atmospheric gases will combine and make oxide. Basically, we have oxygen. It will make oxides, metal oxide. We don't need metal oxide. Those are kind of impurity to the molten zone. If they infiltrate within or inside the molten zone while solidification, then it will simply loosen or lessen the strength of the weld zone, that we don't need, that is not required.
Okay, sir.
Hmm. Any further question?
Sir.
Arc length.
Hello, sir.
Yeah, I'm listening.
Sir, if we have a slab more,
Sorry. Repeat because your
like,
voice is not clear. Hello.
sir, if we have a slab, hello, hello,
Your हाँ say
so if we have
hello.
of more thickness, like say 5 centimeter or 3 centimeter, do just the whole surface or just the edges?
Repeat. I couldn't hear you.
I think you can write on the chat box your
Just
question.
write in the text box. Text box. If we have slab of thickness say 50 centimeter, do we join the whole surface or just the edges? See, joining is your purpose. Means if you have to make a T structure out of two cylinders, then you will make T sections. No, you won't make L section. So that is your purpose. How you will join. It totally dependent on your purpose. How you are making the joint. Where you want to make the joint.
See, the question is whether you are doing a thin sheet or say around 3 millimeter sheet or plate, or you are using a much thicker sheet plates. Okay, maybe 20 centimeter, 20 millimeter or 50 millimeter, as you said. So it's
Yes,
not that every thickness can be welded. Okay, but there are
Acha.
processes which can weld a thicker place also. Like we have not told you about that, but there are processes which can weld thick sheets. So that case will be able to do like that. So typically thicker sheet means you have to melt, go into much deeper. You have to melt more amount of material in both the working plates. You have to deposit more amount of material involving more amount of current, because current is in a way proportional to the amount of heat that is generated. So there are different processes like your submerged arc welding process, which will work in always covered with a flux. At the same time, it will work in the several hundreds of amperes of current. So which can weld a thick plate, 3 millimeter, 3 centimeter plate also it can use. And there are, but rarely will go more than 3 centimeter. Okay. So if you require that thing from the both side welding approach can be done. Okay. But typically many a times if you say I just wedge, some applications it may be, as Rakho Hori has said, some of the applications it may suffice. But for majority application you want to have a full penetration welding. So your question is whether we do just on the edges or we go for a full penetration welding. Okay, have you satisfied with the answer?
Is there any more questions?
Achha, we have uploaded both the videos, today's videos and milling. I think milling video is missing. So milling video link also we have given, and today's PPT also. Okay, in PDF file we have already uploaded in the under Teams. Under files you will find them. Okay, so please go through them. Okay, and if you have some more doubt, we can answer in the next class. Okay, fine.
Acha. Okay.
Okay, we'll call it a day. Thank you for attending for so patiently, and
Thank you, sir.
I appreciate your questions also. Okay, thank you all.
Sir, excuse me,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank
Sir,
you.
sir, in the next class also we'll continue with welding.
Sir,
Sir,
sir, how will the assessment be done, sir? Saying assignment, tutorial sheet,
Assignment.
so quiz. Hello, sir.
Hello.
Sir,
Hello,
present.
sir.
Hello.
I think sir are not present.
I think meeting is over.
यार क्या है यार? Yeah. Anyone know how will the assessment be done in this course?
No.
Sir, sir, group it is record.